This series is provided by the Robert Wood Johnson Foundation, making grants to improve the health and healthcare of all Americans. And by Mutual of America, building America's future through pension and retirement plans, encouraging dialogue and discussion. The spirit of America, Mutual of America.
My dad was a wonderful father when he wasn't drunk, and when he was drunk, he just wasn't there. My dad was an alcoholic, and so was his father.
I had always been very interested in school. I loved school. And all of a sudden, my motivation for school became unimportant. Drinking and hanging out became much more important than school.
I got through college and graduate school on speed.
I started drinking vodka, and I fell in love with vodka.
The first time I ever did coke on my 25th birthday.
Yeah, beautiful Miami.
Within 6 months, I was a full-blown addict.
It replaced everything in my life that I loved.
I think habits do.
During my cocaine days, I was drinking at least 2 to 3 six-packs a day. Had to take the edge off, so it's an incredible balancing act. Just the right high and the right low.
I got introduced to heroin. My whole personality changed. I would fight.
Started doing crystal meth in 1989. I mean, I could work forever, and I did. I mean, I got promoted from general manager to vice president of quality assurance to executive vice president of quality assurance in 3 years.
When I came out of my mom's room, I didn't say, when I grow up, I want to be a drunk, I want to be a tramp. I didn't say that. And I didn't want that, but that's what happened.
How did it happen? How could it happen? I'm Bill Morton. Now at last, the mysteries of the addicted mind are beginning to unravel. Over the past decade, some extraordinary scientific expeditions into the workings of the brain have enabled us to understand how it is that some people will sacrifice everything, their family, their work, their health, to satisfy their hunger for a chemical fix. We're learning how drugs enter the pathways of the brain, what scientists call the reward circuit, where we experience joy, pleasure, euphoria, how they alter the brain to create something that didn't exist before, and what all this means to motivation and behavior. Call them archaeologists of the brain, these neuroscientists. Using new imaging technologies, they're digging deep into the complex riddle of addiction.
Okay. While Sherry's getting her in the bite part, you might want to hook up this component.
Now,
Just going to test this ID while they're doing that.
Here you go, Denise.
Denise is a cocaine
Yeah, I think
user.
it's some tape, Mary.
She has volunteered for research at Massachusetts General Hospital in Boston, where neuroscientists are taking pictures of her brain on drugs.
Okay, Denise. Now you're going to hear the beat for about 2 minutes. Just slow, loud beats. Hold real still.
This gives us a picture of the thinking, feeling, living human brain as it processes information over time.
Those are good-looking images.
We literally see the activation of specific circuits in the human brain.
Nice-looking brain. Great. Just cleared that component. We'll get ready to replace the experimental slices. Excellent. This person had a significant amount of rush and high from the test dose. So I suspect that we'll get a wonderful effect.
Because she is awake and functioning,
The scientists can talk to Denise while they x-ray her brain's blood flow.
You'll start to feel something in your left arm. That will be the infusion.
It is a delicate and carefully choreographed process.
You may get 2 doses of saline, you may get 2 doses of cocaine, or you may get one of either, okay?
Dr. Hans Breider is the team leader.
Let's do it. Okay, we have 10 seconds until we start the infusion. 6, 5, 3, 2, 1, now.
Dozens of images taken over a short period of time show where in the brain the drug is active, where craving for the drug actually takes place. Dr. Steve Hyman once directed Harvard's initiative in mind, brain, and behavior. He now heads the National Institute of Mental Health.
So here it is. We turn on this checkerboard pattern, and now we're going to be able to see whether, even in the presence of cocaine, we get the normal expected activation of the visual circuit.
That's a nice acquisition.
As the drug is coursing through her veins and getting into her brain, we're going to be able to get a picture of her brain as she is reporting to us.
She can actually tell you what she's thinking or feeling at any moment you're taking a picture of the drug impacting on a part of her brain.
That's exactly right. We're getting a map of her feelings. We're getting a map of what structures in her brain are active as she reports the feeling of high, as she reports later on after the drug wears off, the sense of craving or wanting the drug. Literally, what this allows us to do is get an image of desire in the brain. Now, this is not only interesting from the point of view of fundamental aspects of our humanity, it also has a practical significance for people who are addicted to drugs. Because if we know where in the brain drug craving is, we can start to think about what chemicals are involved, what the timing is, and perhaps come up with better treatments which can be administered to affect the right cells, and very importantly, at the right time.
There's something about these biological changes that are going on at the neuron level, at the cellular level, at the molecular level, that gets translated into compulsive, uncontrollable drug use. The electric current comes down the neuron, the little chemicals get released here, got it? These are the neurotransmitter, dopamine, coming out of the first cell.
Dr. Alan Leshner is director of the National Institute on Drug Abuse, which provides more than $400 million annually for research on addiction.
Addiction is fundamentally a brain disease. Let me just show you a diagram.
Leshner is often on the road to talk about the findings of addiction research. Today, he's at Eastern Middle School in Silver Spring, Maryland.
The problem is it's not just a brain disease. Addiction itself is actually a result of a combination of environmental factors, historical factors, the physiological state of an individual, like their genetic background. They all come together through the brain to produce addiction, but it's not any one thing all by itself doing it.
You call it a disease.
It's a disease because it's a result, actually, of drugs changing the brain in fundamental and long-lasting ways. And it's a chronic relapsing disease because typically, sadly, but typically, people don't have only one episode of addiction. They have repeat episodes. Addiction is not a voluntary circumstance. It's not a voluntary behavior. It's not just a lot of drug use. It's actually a different state.
I liked the effects. I liked it. I liked it, what it did for me. Because it took me from reality and put me wherever I wanted to be.
I thought it made me smarter. I thought it made me more creative. I thought that I was more powerful. It made me complete, no question about it.
For how long?
For 20 minutes, and then I could do another line.
There are common mechanisms in the brain that are triggered by every major addicting substance. Now, we don't know for sure that this is the common essence of addiction, but it's very striking that all addicting substances cause a change in dopamine levels. That's nicotine, heroin, cocaine, amphetamines, alcohol, marijuana, all produce changes in dopamine functioning in the same general area of the brain.
Dopamine is part of our brain's vast and intricate communications network. All of us have some 100 billion cells or neurons in our brains. They communicate with each other by electrical impulses and the release of chemicals. These chemical communicators are called neurotransmitters. Dopamine is one of them. When we have a pleasurable experience, the brain releases dopamine.
So, for example, normally we might have a very positive experience and get a certain amount of dopamine release. We might have a wonderful meal. We might accomplish something. We might win a race and get a certain amount of dopamine. What the drug abuser finds is that they can literally fool the brain. They short-circuit the brain. They take drugs and they get this sense of well-being, of happiness, of euphoria. And what's really striking is that it's reliable. When they take cocaine, when they take heroin, they can produce this again and again on a regular basis. None of the vagaries of, will this experience live up to expectation? And that's what gets them in trouble. Because by bombarding the nucleus accumbens and the rest of the brain with more dopamine than it had ever seen before, the brain adapts. It literally becomes dependent on the drug. It is changed by the drug. You can no longer feel okay once you're addicted without the drug.
In his lab at the National Institute of Mental Health in Bethesda, Maryland, Dr. Hyman and his researchers want to know more about how drugs chemically seduce the brain.
This crew here is really studying very directly how drugs and neurotransmitters, the chemicals that nerve cells use to talk to each other, make long-term changes in the functioning of the brain.
Have you found the answer to his question about why the brain prefers drugs to broccoli?
Not yet.
We'd all be out of business.
You know that, right? There's nothing in broccoli that taps into brain reward pathways. All of the most addictive drugs are natural plant products initially. So cocaine came from the coca leaf, tobacco produces nicotine, and opiates came from the opium poppy. Now the chemicals in, say, the coca leaf that produce cocaine fool the brain and literally reproduce, although in massive fashion, the equivalent of the release of dopamine. There's nothing in broccoli that does that. Literally, the chemicals in a small number of plants are Trojan horses. They're masqueraders. They look just like natural chemicals found in the brain, and they fool the brain.
So they come in here and they say, that was good, but it really wasn't good.
That's exactly right.
And I'd go to a board of directors meeting, stand up there in a board of directors meeting and give a presentation. And I would give this image that I was fine, that I felt whole, and that I was competent. And I knew that that night I was going to be going around the back gate of the local Marine base looking for more drugs.
You don't feel like a human being when you're in the throes of this disease, Bill, because the things that you're doing are inhuman. You're lying, you're stealing, you're cheating.
People who are addicted will go to extreme lengths to get their drug of choice, despite incredible negative consequences, despite all kinds of trouble.
This is telling them that they must have it, and it's changing their behavior to get it.
Absolutely. This has been hijacked. This part of the brain is there to say, this is good, this is important, this is what makes the world good for you. And what's happened is that in response to the drug, we have made this part of the brain and associated structures unable to function without the drug. The brain